In this video, we're going to look at topic 64, example 1, translate a function. In part A, they tell us to graph the function f of x equals x squared for the domain -2, 2. That f of x equals x squared is already graphed here in blue. And then it says the graph of g is the graph of f after a translation of 3 units down. Just want to keep that in mind. How are the equations, domains, and ranges of f and g related? So this is kind of the first thing we want to look at, is that every point on the graph of g is 3 units below a corresponding point on the graph of f. And that's where we talk about that shift down, or a translation 3 units down. So g would take any of these points. Let's say we have this point here of -2, 4, and that point is going to shift down 3 places. So that would wind up right here. So that point is going to shift down. And we would do the same thing for, say, 2, 4. That point would shift down here. And when you're talking about those translations down, you're going to do that for every point along the graph. So I can take each of these points, in this case 0, 0, and that would shift down 3 units. So that would be here, and then just continue on. All right, so if I were to take the other units, so this one here would shift down 3 units, and so on. So I'll just draw a quick little sketch of what that would look like. You'd have a point here and here. And any of these points, even the ones along that aren't exactly right on the corner of a grid, that will go down 3 units. So that would drop down 1, 2, 3, and that would be somewhere here. But the point is, your graph is going to keep the same shape and will look something like this. So this was f in blue, and now we have this translation down would represent function g. So the question, how are the equations, domains, and ranges of f and g related? Well, what we did was g of x, or let's change the color, let's keep this color coded. G of x is effectively equal to f of x minus 3. All right, so we're taking 3 places down there. I'm going to keep this in red, but it represents our translation down. So those would be 3 units down. We're taking all of f of x and shifting those values down. Now, as for domains and range, the domain didn't change because we're looking at this kind of this area here. All right, in terms of our x values, we didn't go left or right, so there's still the limits, and the domain is still -2, 2. So the domain remains the same. In this case, it was -2, 2. Now the range of f of x, remember as your y values, was from a minimum of 0, and that went up to here, which would be 4. Well, that clearly changed. The range of g of x, since this is being shifted down 3 units, our y values, our range is going to change. So each of those points, now our minimum would be down here at -3, and our maximum would be up here at 1. And if you notice, we shifted down 3 places. 0 minus 3 gives us -3, and 4 minus 3 gives us 1. So you can kind of keep that in mind, that if you have a shift down, your range is going to change. And it'll effectively change the same if you were to shift up. And that's where this translation here, this term, or these sentences, let's say, come into play. They tell us that a translation like this one is a particular kind of transformation of a function, one that shifts each point on the graph the same distance and direction. So in this example, all of our points shifted down. In general, if g of x is equal to f of x plus k, so this plus k is important here. If you have something on the outside of that function, so you're adding that k value, then the graph of g is a vertical translation of the graph of f by k units. So if we added k, let's say it was +5, what would happen is our graph would shift up 5 places. Since here we subtracted this 3, that's why the graph shifted down 3 units. Our k value was that negative 3. All right, so let's look at question B. And B is quite similar. You'll see kind of what they're talking about as we go through it, and you'll see how similar it is to A. So in part B, graph the function f of x equals x squared. Again, that one's already graphed. That's the one in blue. Let's label that as f. For the domain negative 2, 2, same domain as we had before. The graph of the function g is the graph of f after a translation 3 units to the right. How are the equations, domains, and ranges of f and g related? So every point on the graph of g is 3 units to the right of the corresponding point on the graph of f. So I'm taking all these points, and like we did in part A where we shifted down, everything went down 3 units. This time we're going to shift our values or our graph to the right. So this point here will shift right 3 units. So we'd have a point here. This point here would go 3, so we'd have 1, 2, 3. Our vertex would shift over 3. I'm actually going to run a space here. This graph was supposed to be a little bit larger, but the point should be over here. So this would be at 5. And then we'd have this function here. And we could label that as g in this case. Probably should have used a different letter from part A, but you get the idea. Every point on the graph of g is 3 units to the right of the corresponding point. So we did this here, right? We shifted everything over to the right. So again, we want to talk about domains and ranges. Or sorry, let's look at the equation first. Apologize for that. So g of x is effectively a translation of f of x. And what's happening is the graph is being shifted to the right. And this is where horizontal translations, left and right, gets a little tricky. We still have f of x, but if we're moving to the right, we're actually going to subtract 3. And as the lessons go on, we'll get in way more detail on why that's actually minus 3. But for now, just remember it's confusing and that it's actually backwards. So if we're shifting to the right, you would think plus, but it's actually a minus 3. All right, we're changing that function in that way. Now, my domain, so we talked about the domain of of f of x. We said that was originally negative 2, 2. And we want to look at the domain of g of x. So we shifted our graph. So the x values are going to change since we moved left and right. So instead of being here and here as our limitations, those have been shifted to the right. So my domain is now going to be from 1, right, that's right here, to 5, which is off the graph, but you can see that 5 went over there. And very similarly, that shift right, these are going to change by 3. So we're adding 3 to each piece. And again, we're adding 3, which is confusing when it comes to this part here where it's minus 3. But we'll go into way more detail on that later on. Just take my word for it now. It's tricky. It's the opposite. Now the ranges, so the range of f of x, we talked about that being 0 to 4. That's from the last example. And our range, let's keep this color-coded. Our range of g of x, well, we didn't shift up or down at all. We went to the right. So your range actually is not going to change at all. It's still going to remain 0, 4. So what you'll find is that when you have translations or some kind of transformation vertically up and down, that's your y-axis. So your y values, your ranges will change. And when you have a shift left to right, that's along the x-axis, that's going to be your x values and your domain will change. There is the possibility that you could have a shift left, right, and up, down. So you might have both a vertical translation and a horizontal translation. So mentioned down here, in general, if g of x is equal to f of x minus h, that's where we talked about that minus 3, then the graph of g is a horizontal translation. So that would be a horizontal translation of the graph of f by h units. Horizontal translations are backwards. One last time, if you subtract, you're actually moving right. Let's say this had been x plus 2. So in here, let's say we had f of x plus 2. That actually would have been a shift to the left. We'll get in greater detail on that as the lessons go on. But for right now, just know that the k value determines whether it shifts up or down, and the h value determines whether it shifts left or right.